Hello again and welcome back to the ADEPT tutorials. Today we're going to be looking at some of the more advanced features of ADEPT, including the options and special outputs menus. So to start off, we'll go ahead and start up ADEPT with java-jar, adept.jar just like before. But we're also going to add in a command line argument here. We're going to give it star.txt to grab all the text files in the directory. And these are going to be the same 10 input files that we used in the basic tutorial. And as you can see, here they are. And we didn't have to use a file chooser like we did in the basic tutorial since we gave adept files to start with. All right, and then we'll go ahead and give it the same three variables here just to keep things consistent. We had down equal time at the origin, and then kinetic energy. Okay, and a couple things that I didn't cover in the basic tutorial that I'll just go over here really quick. Some stuff with the result panel here. The first thing is that you can, if you'd like, you can sort the rows according to one of these values in the column. So say I wanted to sort these rows by their value of U. Just go ahead and click the header at the top, and it will sort them for you. 1, 2, 3, and then these are 4. If I wanted to do, say, kinetic energy, then there we go. And if you want to put them in the opposite order, like it did here, you just click it again, and it will put them into. Right now they're in ascending order, and then this is descending order. Okay. So then we'll go ahead. Oh, one more thing was that you can switch the ordering of these variables. Say if you wanted U on the far right, you use these little arrows here to do that. So if we want U on the far right, we'll go ahead and click that down. Now it's in the middle, and then we'll put it there, and then we click update, and now it's on the right there. And then to remove a variable too, pretty simple, just click the minus button there. Okay, so let's go ahead and get into these options here. First one will be this include value errors in results. So if you're familiar with Quest output, a lot of the input parameters, in fact all of the input parameters, do not require an error. They don't have an error associated with them. Things like U, temperature, and things like that. But a lot of the outputs from Quest do have these errors associated with them. All the correlations have errors. Energies such as kinetic energy, total energy have errors associated with them. So if you wanted to save those errors, to put them into this result panel with all the other values, just go ahead and hit include value errors and results. And now values that do not have errors will just stay as they were, and then values that do have errors are going to get a new column. Like kinetic energy here got a new column called kinetic energy with error. And this is just the error associated with the kinetic energy for whatever file. And then we can go ahead and see for the correlation as well. If we scoot some stuff over, there we go. Oops, oh, wrong one. This one here. There's the error for the correlations there. Okay, so there's that, and we'll go ahead and declick that just to get rid of some of that clutter. And another thing that I did cover in the basic tutorial that I'll just cover again here real quick is that we can include file names in the results. So here, this is the name of the file that has this data with U equals 4, kinetic energy equals to negative 0.78, etc. And then the next thing was to include interfile average values and errors. Now these values that it's going to generate are based on the values in all files. They're not directly pulled from each file like these ones are. So we'll go ahead and click this. And now we have the average value for all of these. So first, if we have U, if you found the average of that, it would be 3.4. And then we have the error, which is you can find the formula for the error in the user's guide. But this is the error across all of the files for that value. And if we have the file names selected like we do now, those rows will show up as average and error. So when we end up like sorting things, it'll still let you know which one is the average, which is the error. Whereas if you didn't have that selected, it could easily get lost which one is which when you're doing the sorting. So we'll go ahead and re-enable that just to be clear. Okay, and the next thing I believe is these special outputs. So we'll go ahead and start on those. So the correlation printout takes the points from a correlation I, in from one file and one correlation. That's not this isn't a rule for this output menu, but these two uh, special outputs in particular do only use one file and one correlation. So the results that end up in the result panel are from only one file and one correlation within that file. So first we'll do the correlation printout, which prints out some of the data or all of the data relevant to one correlation. Um, and there I just picked a file, and now you pick whichever correlation you want. We'll do the same down equal time greens function. And then you can output two methods with this correlation printout. You can either print out the perimeter by index, which I'll explain in a second, or you can print out all points from the correlation from that 1/8 wedge, which I'm going to explain in a second, um, just by Euclidean distance. So here I'll go ahead and describe what the perimeter is talking about. So the points given to us through Quest are only 1/8 of the entire graph. This is an example of, say, a 4x4 lattice where it goes from -2 to 2. And the Quest output only gives us this 1/8 wedge. We could extrapolate the entire graph by reflecting over the x equals y, and then the x-axis, and then the y-axis here would give us the entire graph. But since we're only given these points and it's kind of redundant to hold them all, we can just look at the ones that are important. Obviously, these ones that aren't reflected. So if we wanted to look at just the perimeter, say these most extreme values, the way these are indexed is going along this right triangle, going first along the x-axis, and then up the max x axis, and then back down diagonally. So if you were to look at this as coordinates, you would have 0, 0, 1, 0, 2, 0, 1, 1, 2, 1, and 2, 2. And then the actual perimeter indexing would go 0, 1, 2, 3, 4, and then 5. So this would have 6 points for the perimeter. Okay, and then if you were to click the all by Euclidean distance, that would include all these perimeters plus these points inside. Now, granted, the 2x2 here, or 4x4, sorry, lattice wouldn't have any points in between. But in our situation, we have these are all 8x8 lattices, so there would be some. Actually, I can go ahead and draw a little shape here. If we were to, let's see, we'll go ahead and rotate that. So these inner points would then also be in that Euclidean printout. So we'll go ahead and first do the perimeter by index, so we can just kind of see what I mean, and then you can also show the errors for those correlation points as well. By default, those do not show up. So we'll go ahead and print that out. And here, let me just bring this back up again, just so we can follow along. So the index here starts at 1, and then it would go 1, 2, or starts at 0, goes 1, 2. Let me move that over there. 2, 3, 4, and that would be this this bottom right point. Then we go 5, 6, 7, 8. 8 would be the top right, and then 9, 10, and 11 would be these hypotenuse points. Okay, and now and then those are those points there. So if you wanted just the whole perimeter, you could have it like that. And then if you wanted it by Euclidean distance, we'll go ahead and click that and click the correlation. And here they are. Here's the distance, and then the value for that correlation. And these are not by default sorted by Euclidean distance. It goes x equals 0, count, or y equals 0, counts those, and then goes up a row, up a row, up a row. But we can easily, like I said earlier, sort this by distance just by clicking the top there. And there we have 0 to 5.656. Okay, and then the last output is this reflected correlation set. So again, we only are given, in the quest output, we're only given this 1/8 wedge of the entire graph. So what the reflected correlation set does is it actually prints out the entire graph, reflected over the x equals y, y, and x axes. So we'll go ahead and do that. And again, these are 8 by 8 lattices. So we're going to be starting at -4 and going all the way to +4. And the y's do the same, -4 all the way up to +4. So we'll go ahead and scroll up here to the origin, 0, 0. And we have that value, and that value will never be seen in any other point because all of the points are reflected around the origin. And we will see that 0, -1, and 0, 1 do have the same value because of that reflection, and same with the ones above and below that, and above and below that, and etc., etc. Okay, so I believe that's all we had figured out for this tutorial. Join me in the next one. We'll be going over the filters, how to filter your files so you only get what you want. And then in the final tutorial, I'll be going over variable lists and how to create these custom variables. So stay tuned.